Hi, my name is Chris McHenry, and I'm Senior Vice President at Aviatrix, Product Management. And today we're going to talk about a big challenge that many organizations have, especially from a security perspective, when they're trying to defend their cloud environments. So we're going to talk about a unique environment, something that I call an island VPC. Other people call it isolated VPCs, disconnected VPCs. There's a lot of different scenarios here. But we're going to talk about how many organizations found themselves in a place where they really don't have good control of their perimeter. And it's not that easy to regain that control. That being said, before we get to the end of this presentation, we're going to have some pretty good solutions to help you really take control of your cloud environment and ensure that you have compensating controls if you're ever in a position to prevent yourself from getting attacked. So as we take a look at this, it's always important to take a step back and think about how did we get to the point that we are at with our cloud environments today. And it really all starts with the developer. Applications are one of the primary reasons, are really the primary reason why the cloud exists. Applications are critical to making sure that our businesses can ultimately run effectively and efficiently and innovate and be competitive. And the developers really are the center of this ecosystem. Now, when the cloud first came to be, historically, these developers were used to a relatively slow experience on premises where they requested virtual machines and they waited several weeks, and now they get to the cloud, and the cloud was really built for developers. They go to the cloud, they say, hey, I need a VM, I want to build my application, and I know this was really, really hard on-prem. They go to the portal or potentially even use infrastructure as code early on, and all of a sudden, almost instantaneously, they get a virtual machine. And what's more interesting about that is as they go through that process guided them with a bunch of default configurations that allowed them to set up some of the basic other elements that they ultimately needed, storage, networking, as an example. One of the other really amazing parts about cloud is all the added services that come with it. And so in the early days, it was S3. Today, it's things like Bedrock that allow us to really innovate in our applications. And that requires access to the internet because these services live in the cloud, they're publicly available in the cloud. And that user experience, that workflow is designed to make this incredibly easy. And many of the developers don't know a lot about networking. Networking is one of those critical parts. Now, the challenge here is that as you go through this, it's not magic. There's actually a lot of things that happen in order to get us to this point. So we're doing things like selecting IP addresses. The default CIDR range is a 10.0.0/16, right? Which if you're a networking person, you'll look at that and think, oh my gosh, that's going to be incredibly difficult for me to integrate back into my network. But it's an easy button. It allows us to get started really quickly. It gives us plenty of space so that the developer doesn't have to think about whether they're going to run out of it as they deploy more applications. It's going to do something like deploying a NAT gateway in the subnet that allows them to get access to the internet. It's going to create our route tables and automatically configure them. It's going to put a security group in place that has appropriate controls, maybe defending the inbound, but the default posture is allowing all of the traffic outbound. And what's really interesting about this is if we compare it to how things operated on premises. One of the core principles of security design on-prem was the ability to protect yourself at the perimeter, that place where your application traffic and your user traffic leaves your point of control. And in this scenario, we really haven't done much about protecting the perimeter. We don't necessarily even have visibility into all of the things that are communicating out to the internet. And this is an interesting problem, right? I mean, I actually think it's nice and easy for the developer, but it puts us at odds with our InfoSec teams. So I do think it's really important for everyone to appreciate and think about, why is this an important thing for us to consider in the first place? Why were network security controls on-prem so important? And to do this, we're going to take a look at an attack. So there's several different models for thinking about how attackers gain access and ultimately execute their mission inside of an organization. One of the most popular ones is something called the MITRE attack matrix. There's another one called the kill chain, which is a little bit more simplified. This is something that's kind of in between. It's called the unified kill chain. And it really walks through the process that every attack takes when they're going into an organization. It starts with how do they get into the environment. It continues with once they're in the environment, how do they get through the environment, how they move around. This is generally called lateral movement in an environment. And then once they find the thing that they need to ultimately execute, that how do they get out? How do they take that data? How do they execute, if it's a destructive attack or something like ransomware, how do they execute that system? Now, a lot of people think egress network security is in that last phase, that how do I prevent somebody from exfiltrating data? But that is a misconception. So if we take a look at the in phase, that first phase, really what we want to do as security professionals is we want to stop the breach before it starts, right? So looking at things like when an attacker ultimately exploits a vulnerability, the first thing that they're going to do is they're going to download their malware so that they can gain control of the system. Downloading malware is an egress flow. Establishing something called command and control so that they can then give that malware commands, that is an egress flow. If we do an effective job of preventing egress internet traffic, we can actually stop breaches before they start. And this is why this control is one of the most critical controls that organizations have in their environment. One of my favorite stories from this actually comes from the Log4j incident. And I was talking with one of our customers about what they did for Log4j on premises versus what they did in the cloud. And when they had Log4j on premises, it was very, very simple. The only thing they did was they put an egress rule in their firewall that blocked LDAP traffic, which was how Log4j ultimately executed. In the cloud, they had no idea where it was, and more importantly, they had no ability to control it if it was actually being exploited. Egress security controls can give us those effective compensating controls. So why is it so hard in the cloud? That's because our perimeter is no longer something that's physical, right? You can't plug that cable into a firewall. You can't protect it, physically from the internet. We have to think about this more in a software-defined way. We have to think about this more in a distributed fashion. And there's some additional challenges, especially with these island VPCs, that make it incredibly challenging to actually implement that security, right? So it's looking at, you might have multiple different VPCs that have the exact same IP addressing schema. Firewalls don't like this, right? We need to think about how do we distribute that security while the security team still maintains the ability to centralize control, right? If we're doing this in a traditional method, the security team is going to come in and they're going to actually impose on the cloud team, and they're going to say, hey, I want you to completely change your architecture. I want you to re-IP your applications. I want you to deploy a centralized firewall and do all of this complex routing in order to get traffic into that firewall. And oh, by the way, it has to be my preferred security vendor. And yes, that's true. That means you can't use policy as code, and you're going to still wait 2 weeks for a change request for your firewall rules. None of this flies in the cloud. This is the wrong way to do it. In addition to that, we talked about island VPCs, right? So these are VPCs that may never need to be connected to the corporate network. A lot of modern applications only work via API access to third-party services, right? Those APIs can be, controlled. They can be encrypted. They can have authentication added to them. They work over the internet, right? And actually, to some extent, when you connect these VPCs to the network, even if you even can, if they don't have overlapping IP addresses, if you can even connect these to the network to get them to a firewall, then you might actually expose yourself to more lateral movement in that second phase of the attack. So finding ways to distribute the perimeter effectively, not just from a management perspective, but also from a cost perspective. Most traditional firewalls are not cost effective or management effective to distribute them into these island VPCs. So we really need a better way. And add on to that the fact that now all of a sudden we're dealing with Kubernetes, and Kubernetes is consuming more IP addresses than anything else, and these workloads are incredibly dynamic. So imagine a scenario where you have a container environment in a traditional data center, and every time a new container spins up, you have to add a new firewall rule. Absolutely not. That won't fly. We need security that's significantly more integrated into the environment. And this is where Aviatrix comes into play with our distributed cloud firewall architecture that allows you to have multiple distributed enforcement points across all of your accounts in AWS, across all of your regions, centralized visibility, centralized policy control, deeply integrated with infrastructure as code, supportive of integration with things like Kubernetes so that the policy actually follows the workloads as they evolve based on their identity, things like namespaces and pods and labels. And it does it without any need for agents, without any need for sidecars, without the need to deploy a service mesh. Sounds too good to be true, but this is what happens when you refactor and you re-architect the firewall to be optimized for the cloud. Now, our goal here at Aviatrix is to make a meaningful improvement in customer security postures. And that's not just about having visibility. It's not just about having the opportunity for a control point. It's not about just being able to do things that are best practice, like blocking threats or known malicious communications. We want to help organizations move towards zero trust. So at AWS reInvent this year, we announced our egress security workflow that allows you to go in, immediately onboard your accounts, and get a score that helps you identify where you have unprotected egress traffic. Now, in addition to that, most organizations don't necessarily know what their applications are doing, or they might not know what policies they need to put in place. They might not know what dependencies they have. And so this is an amazing opportunity for us to help with generative AI, so that now, throughout this process, Aviatrix will actually baseline the dependencies that your applications have, make recommendations around what a zero trust policy should look like. And in addition to that, we'll give you customized recommendations around why those services are in use and whether they might be potentially suspicious or not. So it's not just about looking this up in a known categorical database. These are recommendations that are customized for your environment. This is a dev VPC. This is communicating with a production API. That might be suspicious. You might need to take a look at that and see whether that's intended communications. So with that, we're going to dive into a quick demonstration on cloud perimeter security, leveraging our new Aviatrix platform as a service offering, so that you can quickly deploy this with minimal or no disruption to your developers. So here we are. The only thing we've done up front is we've onboarded our AWS accounts. This can be done with an IAM role as well, so they can be very specific about the environment. You can see we have 2 VPCs here that need to be protected. And the first thing that we're going to see is when we log in, you can see we've got our egress security score. We can see the different phases. We've got unprotected VPCs. We got VPCs that might have some block rules, but we also have VPCs that are ready to be moved into a zero trust mode. To onboard a VPC, incredibly simple. All you do is select that particular VPC, select the subnet that you want to go into place. Now, Aviatrix in this scenario is in a one-for-one replacement with the NAT gateways that you have in that environment. So we're not adding any additional latency. We're actually taking over the existing hop in the network. We're also mitigating that cost because you're not paying us for data transfer. It's a flat rate for that VPC to protect that VPC. So in many cases, you will save money by deploying Aviatrix. Now we moved that VPC into monitor mode, and before you even enforce policy, you can see we moved our security score a little up because being able to see things is an important part of the security posture. We're also starting to baseline all of the network communications in the environment so that you can then make policy decisions. Now this is really helpful for other reasons too, right? You might actually be able to understand where your egress traffic is going. You can start to look at how I might be able to save cost or optimize cost in those environments. You can look for troubleshooting capabilities, right? So if somebody thinks that it's communicating to an application team, thinks it's communicating a particular way, we can go validate that based on reality. Now, once we've baselined the application for a while, we're actually going to move it from monitor mode to protect mode. And this is where the generative AI features come in. And this is really, really powerful because it's customized to your environment. It's not based on any threat analysis. It's actually looking at indicators in your environment to figure out whether things are potentially malicious. Now, what you can do here is you can use this to send a reduced list to your app teams to validate if you want to do that, or you can even make decisions as a security professional on your own. You can even dive into any of the individual domains that are being communicated with and get a detailed description of what that service is and why it might be in use for your application. Now, in this scenario, we're going to automatically create a policy by removing the things that are known to be suspicious, and Aviatrix is going to recommend a zero trust policy for that VPC. So immediately we baseline for several days. We've understood the network traffic. We've used generative AI to make recommendations around our policy is, and we have moved this into a zero trust posture. Now, if an attacker tries to get in, we will stop them before the breach even starts. They won't be able to download their malware. They won't be able to establish command and control. And you can see as soon as we do this, we're immediately making an impact as well on our security posture. So, still some work to do. We got a couple more VPCs to protect, but we've already made a meaningful improvement in our cloud environment. So what's really powerful about this, and one of the things that Aviatrix is incredibly passionate about, is that we don't think it's a trade-off between the developer experience and the goals of your information security teams. When you use Aviatrix and you implement cloud perimeter security, you can get cloud network security that both the cloud teams and the security teams love. So with that, if you want to learn more, you can click on any of these links, take the QR codes, learn more about our cloud perimeter security solution, which is what we discussed today. You can always request a demo, or you can try Aviatrix for free for 30 days on the AWS Marketplace. Thank you very much.